Hi, this is Edexcel IAL Mathematics Mechanics M3 June 2022 paper discussion. All the questions will be discussed here in this video. Okay, the first question, a particle P moves in a straight line with simple harmonic motion between two fixed points A and B. The particle performs two complete oscillations per second. The midpoint of AB is O and the midpoint of O and midpoint OA is C, right? The length of AB is 0.6 meters. So they are saying AB, we put it on a diagram. So A and B are 2 points. So A and B are at a distance of, it's given the distance of 0.6 feet apart. O is the center, they are saying. So that means they are saying the particle is oscillating between A and B. Means those are the extreme positions. You know, in simple harmonic motion, the amplitude is the maximum displacement from the equilibrium position. In simple harmonic motion, all the displacements are measured from the equilibrium position. You must know what's the meaning of equilibrium position. Means the point at which the resultant force becomes equal to 0. The point at which the resultant force becomes equal to 0 is the equilibrium point. Or when the particle comes to rest, the point at which it comes to rest is the equilibrium position. That always lie at the mid of the complete extreme position. Say for example, here it says the particle is oscillating between A and B. So A and B are the extreme positions. Amplitude is the maximum displacement that will be equal on either side of the equilibrium position. So O is the midpoint they are telling. So O is the equilibrium position. So here AB is given as 0.6 meter, means we know amplitude will be half of it. So amplitude of the oscillation is 0.6 divided by 2, 0.3 meter is the amplitude. And also they are saying the point between A and O, the midpoint is C, that we'll think about it later. And they are saying the particle completes two oscillations per second. That means time taken to two oscillations per second. So that means in 1 second, two oscillations means that is frequency. Number of oscillations completed per second is the frequency. Frequency is 2 seconds. 2 hertz. Frequency is 2 hertz, and we know that omega equal 2 pi f, or you learned that in IGCSE, frequency equal 1 over period. Time period is half. 1 over f means half, that is 0.5 seconds. Anyway, omega equal 2 pi f or omega equal 2 pi over t, we can use it. So the question first part is find the maximum speed of P. Okay, we know that. The equation, we use first part. A part. We know the equation given in your booklet, V squared equal omega squared into A squared minus x squared, where simple A is the amplitude, x is the displacement. Always x is measured from the equilibrium position. They are asking to find the maximum speed. So you know that when x becomes 0, this expression V will have the maximum value because we are subtracting x from A. So when x equals 0, V will be the maximum value. So x equals 0 means I told x is always measured from the equilibrium position. So the maximum speed occurs at the equilibrium position. So they ask you to find that value. So we can say when x equals 0, V equal V max. So V max equal V max squared equal omega squared, x squared we put 0, omega squared A squared. So V max equal A omega, omega A. Right, we know the omega equal 2 pi f. A we found it, substitute, you will get the answer. So V max equal omega equal 2 pi f into A. So that is 2 pi into f is 2, A is 0.3 meters. Solve it, you will get the maximum speed. That will be equal to 3.77 meter per second. That's the answer for A part, question number 1. Okay, so B part, find the time taken by the particle, find the time taken by P to move directly from O to C. So O to C means from the equilibrium position to C. So we know this distance or this displacement is half of AO, which is 0.15 meters. Okay, so that means we should take like this. If it is at O, how long will it take to reach C? If it is at O, so there are two equations we have that is related to displacement and time. We have two equations related to displacement and time. They are x equal a sine omega t and x equal a cos omega t. Okay, you must know where to use which equation. Say, you know, when you put t equals 0, sine 0 equals 0, so x equals 0. That means initially, or the question is something like that. Find the time taken by a particle to move from equilibrium position to a particular displacement. Equilibrium position to a particular displacement. That means it was at equilibrium position. Now, how long will it take to reach a particular point? Means you have to use this equation. Now, when you put t equals 0, you will get x equal a. That means it's at the extreme position with an amplitude. Is it? That means the question is something like that. If the particle is, what's the time taken by the particle to move from extreme position to a point? Say, for example, if they ask how long will it take to move from A to C or C to A to C or C to A, then you should use A cos omega t. Also, better you must know that the time taken to travel from time taken to travel between 2 points is the same regardless of direction of motion. That could be proved, I don't want to waste time. But you must know that the time taken to travel between 2 points is the same regardless of direction of motion. For example, the time taken to move from O to C is the same as the time taken to move from C to O. There you can use, whether the question is related to the time taken to move from O to C or C to O. That means the center is involving, the equilibrium position is involving in that question, means you must use st equal a sine omega t. But if the question is something like, what's the time taken to move from A to C or C to A, the time is the same. A to C and C to A, the time will be the same for that two motions, A to C or C to A, the time will be the same. If the question is something like that, A to C or C to A, you must use x equal A cos omega t. Remember that. So here the question is, find the time taken by P to move directly from O to C. O to C, even if they are C to O, the same equation. So I'm going to use x equal A sine omega t. So that means x is 0.15. Amplitude, we know that amplitude is 0.3. Sine omega 2 pi f. So omega 2 pi f, 2 pi. Frequency we know 2 into 2. Time is the question. We need to find the time. Solve it. Your calculator must be in radian mode. Solve it. You know how to solve. You will get t is equal to 0.042 seconds. So the time taken to travel from C to O or O to C, the same time. Okay, question number 2. This diagram is given. Hemispherical bowl of internal radius 6r, this is the 6r, the radius, this is the center O, is fixed with its circular rim horizontal. So the rim is kept horizontal. The center of the circular rim is O, that is O, and the point A on the surface of the bowl is vertically below O. So here is the A. A particle P moves in horizontal circle with center C on the smooth inner surface of the bowl. So the center of the circular path, I always say it in previous past paper discussions also, in circular motion you must be able to identify the center of the circular path. So the particle P is moving inside the bowl in horizontal circle. For its motion, C is the center, not the O, right? The particle moves with a constant angular speed of square root of g of O. The point C lies on OA. So C is on OA, same vertical line, as shown in figure. Find in terms of R is the 6R is the radius, the distance OC. We need to find the distance OC. Okay, so whenever you get a question related to circular motion, you must be able to identify the center of the circular path. then you must be able to identify the actual forces acting on the particle. Actual forces means we call free body force diagram. If you mark a diagram with all the forces acting on it, that is called free body force diagram. So you must be able to identify the actual forces acting on the particle. Then you must be able to identify or resolve the actual forces towards the center of the circular path. That is called centripetal force, which is given by F equal mr omega square, where r is the radius of the circular path. So the radius is unknown, we need to find it. That is the radius of the circular path, or we can call it as F equal mv squared over r. Okay, so there, yeah, I'm going to use those concepts in this question. Okay, so right, so now we'll first identify the forces acting on the particle. So it's a smooth bowl. So smooth bowl means there is no friction. There will be normal reaction. Normal reaction means like a circle. It's a sphere, spherical shaped bowl means it's like a circle in 2 dimensions. Normal reaction means that will be perpendicular to the tangent drawn at that point, is it? Normal reaction means that should be a force perpendicular to the tangent drawn on it. So you know that on a circle 2 dimension, if you draw a line perpendicular to the tangent, that will pass through the center of the sphere, center of the spherical shape. This is actually hemispherical, but if you draw a tangent here and if you draw a perpendicular line to the tangent, that will pass through the center of the bowl, because for a circle, any line that's drawn perpendicular to the tangent will pass through the center of the circle. So this is a circle but half. So it's a sphere, it's hemisphere, right? So if I draw normal, the normal reaction will pass through O. So I can, yeah, the normal reaction will pass through O. So this is the normal reaction. Okay, this is the normal reaction passing through O. That is one force. I can draw, if you want, I can draw separately the force acting on it. If I draw the particle here, it has the normal reaction that is acting this direction towards center O. And it has its own weight is acting, mg, vertically down. These are the only 2 forces acting. The weight is acting here. I'll draw separately on free body force diagram. mg is acting vertically down. Okay, so the radius of the circular path is unknown. We need to get an expression for that. So if I mark the radius of the circular path from the center to P, that is the radius, let it be R0. Radius is R0. So the line which is drawn from P to C is the radius. So any line that is drawn from the circumference to the center of the hemisphere, that also 6R, is it? Because that's a radius. PO is a radius. So this angle we will take it theta. This angle we will take it theta. So the line from P to O is the line of action of the normal reaction. Is it? Because normal reaction passes through the center because it's perpendicular to the tangent. But we know that the line PO is the radius because it's drawn from the circumference to the center of the hemisphere. So that also 6R. The line drawn PO makes an angle theta with the horizontal that connects P and the center of the circular path. We make that angle theta. The radius R0. So in this right angle triangle, the question is to find the distance OC. Let that distance from O to C, let it be D. We need to find the D, symbol D, right? Let it be D. Okay, now we consider that right angle triangle. Consider that right angle triangle OPC. This is 90 degree. In this right angle triangle OPC, tan theta is equal to OC, that is D, over adjacent, that is R0. I took the radius R0. That is R0. So I took this radius R0. Okay, leave it be. So keep it as first equation. Okay, so now the next thing is something related to forces acting on it. So the particle P is moving on horizontal circle means it should not have any resultant vertical force, because if there is any resultant vertical force according to Newton's first law, it will accelerate in that direction. So there is no vertical resultant force means there are only two forces acting on the particle. So this angle is theta, is it? This horizontal with line, that theta. So r sine theta, vertically if I say r sine theta minus mg must be equal to 0. Because according to Newton's first law, there is no resultant force in vertical direction. So r sine theta equal to mg. Let it be second equation. Now we know the resultant force towards the center of the circular path is the centripetal force. Which is the center? C is the center. So if I resolve the forces acting on the particle towards C, that is the centripetal force, which is given by F equal mr omega squared. Here is r naught, is it? So we'll resolve the forces towards the center. Center is at C. I'll put the arrow towards left because center is here. So r cos theta. Mg is a vertical force. The vertical vector has no horizontal component. You know that. So r cos theta, because when you resolve a vector through 90 degree, it won't have any component. Cos 90 is 0. So r cos theta is equal to m r naught, because that's a radius, m r naught omega squared. So that is the third equation. Okay, we'll divide second by third because I can get the tan theta. Already I know some expression for the tan theta. That's the reason I got these two equations and I'm going to divide second by third. So if you divide second equation by third equation, r sine theta over r cos theta equal mg over m r naught omega squared. So r will get cancelled, sine theta or cos theta, tan theta equal to m will get cancelled, g over r naught omega squared. That is the fourth equation, no problem. I'll put it like many equations are easy to refer. Now tan theta, I know du r naught. Du r naught is tan theta. So the fourth equation and first equation, the left hand side is the same, means right hand must be the same. Therefore, from the first equation and fourth equation, I can say d over r naught. D is the question. We need to show an expression for that. D over r naught is equal g over r naught omega squared. R naught will get cancelled. So D is equal to, I write it here. So D is equal to G over omega squared. But omega is given as in the question paper square root of G over 4R. So G over 4 square root of G over 4R all being squared. Is it? So it's going to be G over 4R, so that's going to be, GG will get cancelled 4R. That means OC equal 4R. That's the answer. That's a question. So OC is 4R. Okay, question number 3. A particle P is moving along a straight line at time t seconds. P is a distance x meters from a fixed point O on the line and is moving away from O with a speed 50 over 2x plus 3 meter per second. Find that deceleration of P when x equal 12 is the first part. So we can put it on a diagram. So we say this is the point O. So at time t, it's at a distance of x from O. It's at a distance of x from O. This is the particle. It's at a distance x from O. So it's measured from this direction from O. That we will take it positive along the direction of motion. It's at distance x from O. And its speed is given as 50 over 2x plus 3. So P is equal to 50 over 2x plus 3 meter per second. That's the speed at time t equal t, at time t, variable t. Okay, so find the deceleration of P when x equal 12. Okay, deceleration. So what is given? Given is speed. So to get the deceleration or acceleration, derivative of speed. So that means v is equal to A part, 50 over 2x plus 3. So acceleration or deceleration, what it is, dv over dt. So here we can't differentiate in terms of time because it's in terms of x. It's a function of x speed. So we can use this way, dv over dx into dx over dt. So dx over dt is v, again it's a speed. So therefore a is equal to v dv over dx. Okay, we'll find the dv over dx first. Then v we know 50 over 2x plus 3. So we'll differentiate this in terms of dx. So that is dv over dx is equal to d over dx of 50 over 2x plus 3. Okay, so you know how to differentiate. So very simple. 2x plus 3 to the power minus 1. It comes like this. We can write, if you want, step by step, d over dx of. We can take the 50 out. Or yeah, I'll keep it all. Just 50 into 2x plus 3 to the power minus 1. 50 is a constant. So that is dv over dx. So that is 50 into, when you differentiate this, minus 1 comes there, minus 1. If you differentiate inside, it will become 2x, that is 2x plus 3 will become 2, then 2x plus 3, minus 1, minus 1, minus 2. So it's going to be minus 100 over 2x plus 3 squared, is it? Okay, so dv over dx, I found it. Now we need to find acceleration. So a is going to be a equal v dv over dx. That is v, we know 50 over 2x plus 3 times minus 100 over 2x plus 3 all things squared. So the acceleration is going to be minus 5000 over 2x plus 3 all the cube. Right, so the question is, find the deceleration of e when x equal 12. So when x equal 12, find it. So when x equal 12, a is going to be minus 5000 over 2 into 12 plus 3 all the cube. Solve it, you will get the answer minus, you will get negative 0.25 meter per second square. So we took along the direction of motion, it's moving away, that we took positive because that quantity is positive, you can see that. So when it take away that direction, acceleration also we took it that direction, but we are getting negative answer. That means along the direction of motion, if the acceleration is negative, means the direction of the acceleration is opposite to the direction of motion. So acceleration opposite the direction of motion means that's deceleration. Okay, so it's the same question, number 3 B part. Given that x equal 4 when t equal 1, that is when t equal 1, the distance from O is 4. Unit not given, doesn't matter. Find the value of t when x equal 12. So we need to get an expression that relates x and t. Right, okay, so we know that speed is given v equal, we know that dx over dt, and we know v is equal to 50 over 2x plus 3. So when we integrate it, we'll get a relationship between x and t. Simple, right? So that means integral of dx, integral of 2x plus 3 dx is equal to in 50 integral of dt. So we know the limits. If you want, you can put plus c constant, or we can directly put the limit. So they are saying when t equal 1, x equal 4, it's given. When t equal 1, x equal 4, that's given. The question is, what will be the time when x becomes 12? What's that? We need to find the t, that's all. So those are the limits. When x equal 4, t equal 1 given. The question is, what will be the time when x equal 12? So I put the limits, we'll solve it, right? So we'll first integrate it. So when integrate, it will become 2x squared by 2, and here 2 and 2 will get cancelled. Limits 4 to 12 plus 3x, limits 4 to 12 is equal to 50t. 50t limits 1 to t. Solve it. So 2 and 2 will get cancelled. X squared 12, that is 12 squared, minus 4 squared, that is 4 squared, plus 3 into 12, x 12 minus 3 into 4 is equal to 50 into, I can put it in bracket, okay, I'll just put easy, 50 into t minus 50 into 1. Solve it. So it's going to be 144 minus 16 plus 36 minus 12 is equal to 50t minus 50. Solve it and get the t. Okay, solve it. You'll get t is equal to 4.04 seconds. It's unit given, yeah. Yeah, unit is not given but second, because speed is given in meter per second, means it must be second. So that's the answer for question number 3, B part. Okay, question number 4, this diagram is given. One end of a light elastic string of natural length L, so the natural length of the string is L, and modulus of elasticity lambda is fixed at to a point A on a smooth plane, so it's fixed at A. The plane is inclined 30 degrees. A small ball B of mass M is attached to the other end of the elastic string. Initially B is held at rest at the point C, so it's at rest at this point B. Rest at point B. Initially B is held at rest at the point C. Sorry, the B is the ball, the point is C. So the ball B is at rest at point C. A is a point where the one end of the string is attached. The ball B is at rest at point C. The length is L. The distance of AB, AC is also L, they are telling it. So that means initially when the ball is at rest, the string is not extended. Okay. The ball is released and comes to instantaneous rest at a point D on the plane. So there is something point D here. So there the speed becomes 0. The final speed becomes 0. And AD is 5L by 4. So A to D, this length is given. AD is given. This length is given. That is 5L by 4. Okay, so initially it was at C where it had the natural length, no extension. When it comes to D, there is extension. It's not a big issue. We can find it. 5L by 4 minus L is the extension of the elastic string. The ball is modeled as a particle and air resistance is modeled as being negligible. Show that lambda equal 4 mg is the first part. Okay, so first we should know actually what is happening. Then we can use the equations to find the lambda. Now when the ball is at C, it is at rest and there is no extension. When you release, you are holding the ball at P and you are releasing it. So it will move down. Why does it move down? The reason why does it move down? The reason there is no friction, the component of the weight of the ball will pull it down. So what will be the component of the weight means I can show it here separately. If the ball is here, initially at point C, this is angle theta. I'll generally show it's angle theta, but they are giving it as 30 degree, doesn't matter, theta. So the weight will act vertically down. You see, the weight of the ball will act vertically down. This is theta, this is 90 degree, means this is 90 minus theta. So the component of the weight along the slope means you should close it. Mg cos 90 minus theta. Mg cos 90 minus theta is mg sin theta. So the component of the weight that is along the plane down is mg sin theta. The component of the weight perpendicular to the plane is, that is perpendicular to the plane is mg sine, move it away such that it becomes perpendicular to the slope, means mg sine 90 minus theta, mg sine 90 minus theta, sine 90 minus theta is cos theta. So the component of the weight perpendicular to the slope is mg cos theta. Remember these components. Then the normal reaction will act perpendicular to the slope. The normal reaction will act perpendicular slope. So whenever the particle or ball, whatever it is, moving along the slope up or down, there is no motion perpendicular to the slope. Therefore, according to Newton's first law, perpendicular to the slope, there should not be any resultant force. Means r minus mg cos theta equal to 0 perpendicular slope. So r equal mg cos theta. Remember these things, you can use it directly. But anyway, earlier also I explained that in one of the papers. Right, r equal mg cos theta. So the component of the weight along the plane down is mg sin theta. Now I don't need to show this weight because I have resolved this weight into two components, perpendicular components, mg sin theta along the plane down, mg cos theta perpendicular plane. I don't need this anymore because there is something related to normal reaction. Okay. Now when you release the ball, at that moment this force is acting along the plane down. That force will provide the required acceleration along the plane down. So what will happen? The ball will accelerate along the plane down. When the ball accelerates, initially the ball is at a point where the length of the string is same as the position from A. But when the ball moves down, the string, the elastic string is going to be stretched. When the elastic string gets stretched, there will be tension. The tension will act upward direction. So the tension will act upward direction. So when the ball accelerates down, mg sin theta minus t is the resultant force downwards. Is it mg sin theta? Minus t is the resultant force downwards, that will provide the required acceleration. This is constant, but t depends on extension. T is equal to lambda x over L. So when the extension of the elastic string increases, t will increase. When the t increases, the resultant force which is acting downwards, which providing the acceleration, the resultant force will decrease. So the acceleration will decrease. Careful, acceleration will decrease. Then when it reaches a particular point at which t will become equal to mg, because this is remaining constant, this is increasing, means there will be a point at which when x becomes to a particular value, t will be equal to mg. Then acceleration will become 0, but still the speed is down. So it will move further down. When it moves further down, now t will become greater than mg because it passed the point where t equal mg. So it will become like t greater than mg, means what will happen? The resultant force will become upwards because t is greater than mg. So t minus mg sin theta will act upward direction. So the ball will have a resultant force opposite to the direction of motion, means the ball will start to decelerate. So when the ball decelerates, the speed will gradually decrease, and finally there will be a point at which, because it's decelerating, anything which is decelerating will finally comes to rest if it has sufficient space to move. So finally there will be a point at which it comes to rest. That happens at D. I hope you understood what is happening now. Right, so if we analyze this, I explain it in terms of forces. Now if we analyze this in terms of energy, what happens? At the moment you release, yes, it accelerates down. So when it's moving down, its vertical height is decreasing. So for example, when it moves from here to here, somewhere here, right? So the height is decreasing, so it's losing gravitational potential energy. So there is loss in gravitational potential energy. So I told up to a point there will be acceleration. Until mg sin theta greater than t, there will be a downward resultant force along the slope, so speed will increase. So that means kinetic energy will increase up to a point where mg greater than t, until that mg sin theta greater than t, mg sin theta greater than c. Until that point, the speed will increase, kinetic energy will increase. So it's losing the gravitational potential energy, it will gain kinetic energy, and also the rubber is getting stretched, the elastic cord is getting stretched, so elastic potential energy also will increase, which is given by half lambda over L x squared, is it? Until that will happen. So until the speed increases, loss in gravitational potential energy is equal to gain in kinetic energy plus increase in elastic potential energy until the point where the speed increases. Then I told beyond a point the tension will become greater than mg sine theta, it will slow down. So that means when it slows down, still it's moving down, but it's slowing down means it's going to lose kinetic energy. So whatever the kinetic energy it's gained, it's going to gradually lose now, but still the rubber cord is going to extend. Still it's going down, so still there is loss in gravitational potential energy is there. Kinetic energy also going to be lost, but elastic potential energy will increase because the elastic string is going to extend further. But finally, when it comes to rest at point D, what happened when we consider the whole motion from C to D? What happened? Speed is 0 here, so no kinetic energy. It gained kinetic energy. Now it lost all the kinetic energy it gained during the motion. So now final equation, energy equation that we could write when it moves from C to D is loss in gravitational potential because it has gone down from C to D. The vertically there is drop. Loss in gravitational potential energy is equal to gain in elastic potential energy. So only thing, the rubber cord or rubber string, the elastic string has extended when it comes to the no kinetic energy. So finally, the energy equation that could be written for the motion from C to D, for the motion from C to D, I can say loss in gravitational potential energy GPE is equal to gain in elastic potential energy. So by using this equation, I am going to find lambda. They asked to find show that lambda equal 4 mg. I am going to show by using this. So students have confusion. What happened to the kinetic energy? It gained, but it lost. Whatever the energy gained in terms of kinetic energy is lost finally when it reaches the point D. Okay, so I'm going to use this equation. So before that, I need to find certain things like how much is the extension, those things. So after that, I'm going to use this equation. Okay, so when it reaches dA part, when the ball reaches D, extension, that is AD is given 5L by 4, the natural length is L, so extension X is equal to 5L by 4 minus L, it will be L by 4, 1/4 of L is the extension. Okay, so how much the vertical height it moves? So you know MGH loss in GP, H is the vertical height. So the vertical height it moved from C to D. I need to find this vertical height. It moved from C to D. This is H is equal to, this I told, now we found it, this is X. So H is equal to, in this right angle triangle, that is in this right angle, H is equal to X sine 30, is it? Sine 30, this is 30 degrees. So this is X, that's the extension. This is the height I need to find, H equal X sine 30. So X sine 30, X is equal to L by 4. Sine 30 half, so it's going to be L by 8. That is the H. Okay, so as I told, I'm going to write that energy equation. Loss in GP, finally, when we consider the motion from C to D, consider the motion from C to D. So I can say loss in GP equal gain in elastic potential energy, no kinetic energy gain because it gained and lost. Elastic potential energy, loss in GP, MGH, gain in elastic potential energy, there is no extension, now the extension is there, so that is half lambda over L x squared. Okay, so MGH, mass is given as M, yes, so that's now value for the mass, so that will be given as M, so Mg, H is L by 8, equal half lambda we need to find, the L is in terms of L, x squared is L by 4 all in squared. Okay, so we need to solve it. So that's going to be now this is MGL, yeah, MGL over 8 is equal to, this is L square L, so lambda L, L square KL get cancels, lambda L over, this is 16, square of this 16 to 32. Okay, so make the L will get cancelled, 8 into 4, so lambda is equal to 4 mg. That's the final answer. Okay, so question number 4b part. Find in terms of G and L the greatest speed of B as it moves from C to D. Okay, so they're asking that, but I already told that. Again, I'll explain. When the ball is released, at the moment when the ball is released, it's at a distance L, which is equal to natural length of the elastic string. So when it is released, at the moment it's released, there will be component of the weight downwards, that is mg sine 30. So the ball will accelerate downward. At the moment it is released, that's the only force. There will be normal reaction, we don't need it, which is perpendicular to the slope. So due to the component of the weight mg sine 30, it will accelerate downwards. When it accelerates, the elastic string will be extended, there will be tension. But when it moves further down, the extension of the string will increase, which is given by lambda over L into x. So the tension will increase. When the tension increases, the resultant force acting on the ball along the slope down this direction, mg sine 30, upwards tension T, which is given by lambda over L into x. So what happens when the ball moves further and further down? Tension will increase when x increases, so the downward resultant force will decrease, acceleration will decrease, but there is acceleration, but acceleration will decrease. When there is acceleration, there will be increase in speed, speed will increase. But at a point, what will happen? The tension for a particular extension x, the tension will become equal to mg sine 30. At that moment, the acceleration will become equal to 0. But still it has speed, so it will move further down. When it moves further down, now tension will become greater than mg sine 30 beyond that point. So the resultant force will be upwards, motion downwards, resultant force opposite to the direction of motion means the ball will decelerate and comes to rest at point D. That we have done it already. But the question here is, find the maximum speed. So maximum speed will occur until the tension becomes equal to mg sine 30. Mg sine 30 is a constant force, is it? There is no variable. So only the tension is changing because x is changing. When the ball moves down, the string is getting extended, so the tension is increasing. So the acceleration will occur until the tension becomes equal to component of the weight along the slope downward. So we will find what could be the extension at which the tension becomes equal to mg sine 30. We will find it. So acceleration will become equal to 0, will become 0 when 0 means at that moment, just at a moment. Beyond that, it's going to be deceleration. Beyond that, the motion will have deceleration. 0, acceleration, I said acceleration, not deceleration. Acceleration will become equal to 0 when t equal mg sine 30. So we will find the t, lambda over L, I am writing lambda over L into x equal mg sine 30. Okay, we found the lambda already. We got the lambda 4 mg. So 4 mg over L times x equal mg sine 30 half. So you will get the extension at which tension balances the component of the weight downwards. So x will be equal to, at that point, L by 8. Okay. When it becomes L by 8, the extension, when the extension becomes L by 8, the acceleration will become equal to 0. Beyond it, it will move further down because the speed is not equal to 0, so it will continue the motion, but beyond this extension, the ball will decelerate. Okay, so now we found at up to what extension there will be acceleration, so beyond it, it's going to be deceleration. So when the ball travels a distance or length of L by 8 from C, that is the extension, ball will have the maximum speed. Now we need to find the maximum speed. So until this point, the speed is increasing. Until this point, speed is increasing. Beyond that point, speed will decrease gradually. And when it comes to D, it will come to rest. It will come to 0. Right. So now we need to find the maximum speed that occurs at this extension. So we can find it in two different ways. One is by using energy equation, other one by using Newton's second law, F equal mx double dot or F equal ma. Right, so either one we can choose, but I'll do the both methods. Okay, so until this extension, we will write the energy equation. So until this point, the speed is increasing, right? So in the first part, when I consider the motion from C to D, yes, speed increased, and I told speed decrease. So when we consider the motion from C to D, first part, I said there is no kinetic energy increase or decrease because whatever the kinetic energy gain is lost. But when we consider the motion from C to this extension, that is L by 8, speed is increasing. So at this point, it has the maximum kinetic energy, maximum speed. So we can write the equation for this motion. Loss in GPA equal gain in kinetic energy, because kinetic energy speed is increasing and until this point. Beyond this point only, speed is decreasing and becoming 0 at D. So gain in kinetic energy plus gain in elastic potential energy. So I'm doing the method 1. Method 1. Right. Loss in GP. So it's going to move from here length of. So the final point where it came to rest is D somewhere there. So this point we'll name it already A, B, C, D. We'll name it E, right? Anyway, we'll name it E. Or yeah. So at this point it has the maximum speed. Maximum speed. So this length is L by 8. So the height it has fallen down until this point. This H we need. This H we need. This is point C. We need this H. So this is the height H. So H is equal to L by 8 sine 30. This is 30 degree. This is L by 8. So loss in GP mg H. H means L by 8 sine 30. Gain in kinetic energy. At this speed, the speed is V max. Maximum speed occurring. I already explained again. Here the speed is 0 because it released from rest. So gain in kinetic energy half m V max squared minus 0. Because I'm considering the motion from C to E. Consider the motion from C to E. I didn't write it here. You can see C to E. Gain in elastic potential half lambda over L x squared. X squared. X is L by 8. L by 8 already squared. Half into lambda over L x squared. X squared is L by 8. Okay, solve it. You'll get the V max squared. So it's going to be mg L. This is sine 30 means that is half mg L over 16 equal to half m V max squared plus lambda we know 4 mg. So 4 mg if I substitute 4 mg here half, so that will become 2 mg. Is it 4 mg if I substitute here half? I just write it 4 mg over L into L squared over 64. So here it will become 2 here, 2, that will become 32. Yeah, check it and solve that one. Yes, so it will become 2, 32. So L squared, L will get cancelled. So MGL over MGL over 32. Check it. Okay, so it will become half 16, 32. We can even multiply with the whole equation by 2. All them get cancelled. So GL over 8 minus, bring it to the left, GL over 16 equal V max squared. So 16 is LCM, so it's, you know how to solve it. That is 16 means 2GL minus GL over V max squared. So V max is equal to square root of this one, square root of GL over 1/4 of GL. That's the answer. Okay, so method 2, anyway you have to do and find the point at which the maximum speed occurs. Anyway, you have to do this also. This I generally did it for method 1 and method 2. Anyway, we must find this one. After that, we can choose either to follow in terms of energy or Newton's second law. So this you must write for both methods. But in the exam, you are going to write only one method. So whatever the method you follow, you should find the extension when the maximum speed occurs. Okay, so now method 2 beyond it I am going to find. Second method I am going to use F equal ma or F equal m x double dot along the slope down. Okay, so what are the forces acting? I already told, along the slope down mg sine 30, opposite tension. So resultant force along the slope down will be mg sine 30 minus t mg sine 30 minus t equal m x double dot means dv over dt. But you know that dv over dt could be written as dv over dx into dx over dt. That is v dv over dx. It's, you know that. Okay, so mg sine 30 minus t, that is mg sine 30 half minus t lambda x over L equal mv dv over dx. That is, you know that dv over dt could be written as dv over dx into dx over dt. Dx over dt is equal. Right. So lambda, we know that we found it in the first part, that is equal to 4 mg. 4 mg we found it that in the first part. Yes, so we'll substitute that. So mg by 2 minus 4 mg x over L equal mv dv over dx. All the m will get cancelled and we need to integrate it, is it? So so that means g by 2 minus 4g over L into x equal v dv. Okay, now we'll dv over dx. Yeah, we'll integrate it. v dv equal integral of g by 2 minus 4g over L x dx. Okay, what are the limits we are going to put it? The limits when x equals 0, that means at this position B, the speed is 0, is it? At the point where it was released, x equals 0, no extension. We are starting this motion from B onwards. So when x equals 0, speed equals 0. Then the maximum speed occurs when x equals L by 8. So the limit here, L by 8, I should put it here, L by 8. L by 8, this limit L by 8, I need to find the V that I know V max. I know that V max occurs when L by 8. Okay, so that's going to be V squared by 2, 0 to V max equal G by 2 x limit 0 to L by 8 minus 4g over L x squared by 2, and 2 I can take it out, x squared by 2, so that 2 I took it out, x squared by 2 I took the 2 out, so that is 0 to L by 8. Okay, solve it. I'll raise it and write it here. Okay, so I'll write it on left, so it's going to be p squared max by 2 equal g by 2 into L by 8, g by 2 times L over 8, to substitute L over 8, then 0, that will get cancelled. So 4g over 2L, so 2g over L, 2g over L, 2g over L, x squared means L squared over 64. Minus 0. Right, solve this one, you will get the V max. So that's going to be V max squared, multiply the whole equation by 2, so GL over 8 minus, this is 32, here L get cancelled, GL over 32, another multiply by 2, so that means 16. So that's going to be 2 GL over 16. So V max equals, same answer we are getting it, x square root minus GL. Yeah. So that's going to be GL over 16. So square root of GL over 4. That's the final answer. 4 meter per second. You can put it here. The units are given in the question. Meters, mg, L. Units are not given, but anyway, you can leave it. Right. So that's the final answer. Either way, you can follow energy equations or Newton's second law. Okay, question number 5. Use algebraic integration to show that the center of mass of uniform solid hemisphere of radius r is at a distance 3 by 8 r from the center of its plane face. You may assume that the volume of the sphere of radius r is 4 by 3 pi r cube. Okay, so it's a standard question. So for that, what we do, this is the hemisphere, it's a solid sphere. We imagine smallest scale inside it. Normally we take, if it is a solid cylinder or solid sphere, whatever the shape, mostly we take a disc inside it, and its mass we consider by considering the density rho. So inside it, at a distance x from it, from the center O, we'll consider a small disc of like this. We consider disc like this. So its distance from the center, let it be x from here. So the center of this disc, let it be c. This distance, let it be x. So its radius, we don't know, we are going to find it, let it be r naught. The radius, let it be r naught. Okay, so we need to find the center of mass of this disc, solid disc. Its center of mass, we know due to symmetrical, it will be at the center of it. So we are going to finally use the definition, mathematical definition of center of mass, that is x bar is equal to sigma mi xi over sigma mi. I am going to use that. That's the final approach, we are going to do that. So where sigma mi is the total mass of the smallest scales we consider, here the smallest scale are the discs. So the total mass sigma mi of the many discs that we are considering inside, that could fill the whole hemisphere. So the total mass will be total mass of the hemisphere, that we can find it by using 4 by 3 pi r cube is the volume of a sphere divided by 2, that will be the volume of the hemisphere into density. Then sigma mi xi means we are considering different many objects. Say for example, if, the basic definition, the idea of center of mass is if there are system of particles or system of objects, there is an object or particle, its mass is m1 at a distance of x1 from this point. So we are measuring the center of mass from this point, let it be x1. There is another object that has mass m2, its distance is x2 from here. There is another object m3, its distance is x3. M3. Like that, there are n number of particles or n number of objects. We know the center of mass of them from the O. So if this is Mn, the mass, its distance from here is xn. So how do we define the center of mass? By using this definition. So that means center of mass of the system of these particles or center of mass of the system of these objects is given by sigma mi xi. That means summation of mass into one by one we find mass into its distance of center of mass x1, then mass m2 into its distance of center of mass from the point O, mass into its distance. Like that, we summation, we add all the masses into the center of distance of center of mass, then divide by the total mass of these objects or total mass of these particles. Then we solve it, we will get the final center of mass of the system of particles or system of objects. So here we are going to consider disks, several disks. This is the disk. There could be another disk. Like that, I can imagine several disks that could fill up completely the hemisphere. So I know the center of mass of this disk is at C from O. That distance I am taking x. The radius of the disk I consider inside the hemisphere is R0. So that R0 I am going to relate to x by using this method. This is R0. Let it be R0. The disk, the center of radius R0. Okay, so the distance, this one is R. This distance is R because this is the center of the hemisphere. This is on the circumference. So this length is R. So I can say R0, the radius of the radius of the disk that I consider inside the hemisphere, R0 is equal to Pythagoras theorem. If I consider for this right angle triangle, if I use the Pythagoras theorem, R0 is equal to R squared minus x squared to the power half or square root. Okay, that is R0. Okay, so what could be the mass of this disk, Mi, the mass of that disk? There are several disks, could be filled the hemisphere. One of the disks I took it, so its mass is equal to its volume pi R0 squared into the thickness. I took the thickness of this disk or the height of the disk dx, pi R0 squared dx. Because at distance x, the thickness is dx. This thickness or the height could be taken as dx. So pi R0 squared dx into the density, let it be rho. Okay, so that could be written as pi instead of R0 squared, R squared minus x squared rho dx. That is the mass of that disk. Okay, so you know that the total mass of several disks, when I add, that will become the mass of the hemisphere. So that is sigma mi. Sigma mi. I need sigma mi means if I add like this several disks, this definition, sigma mi is the total mass of the hemisphere. That is 4 by 3 pi r cube. That is for a sphere. This is hemisphere, so into half into rho. So that's going to be 2 by 3 pi r cube into rho. Okay, so I'm going to use this equation now. X bar, that's the center of mass of the hemisphere, is equal to sigma mi xi, summation of the m into xi for the relevant each and every disk. So x bar is equal to sigma mi xi. So mi, I know that pi r squared minus x squared rho dx into x over sigma mi, that is 2 by 3 pi r cube rho. So rho and rho will get cancelled. So it's going to be pi and pi will get cancelled. So 2 by 3 will get 3 by 2 sigma r squared minus x squared into x dx over r cube. It's correct, no? 3 by 2 pi get cancelled, rho yes, r cube. Right. Now summation with variable x is a variable, because when I consider different disks, x is going to be a variable. So summation with variable x is going to be integration. So now x by is equal to 3 over 2 r cube integration. So this x could vary from 0 to r squared minus x squared. So r squared into x minus x cube dx. X I multiplied r squared x minus x cube dx. So we'll continue. This is going to be 3 by over 2 r cube. So this we can integrate step by step. Together I'll do it. So r squared x squared by 2. So I integrate it, r squared x squared by 2. If we integrate this one, x squared by 2, the limits I'll put it 0 to r minus 3 over 2 r cube. I can put that common. It's okay, I'll put it as common, that one. 3 over 2 r cube. So r squared x squared by 2 minus x to the power 4 over 4, 0 to r. Okay, solve it. So it's going to be here r squared, so r to the power 4. So it's going to be, I'll continue here. Okay, so x bar is equal to 3 over 2 r cube. This is r squared, here r squared by 2, so r to the power 4 by 2 minus r to the power, if you substitute r to the power 4 by 4. Okay, solve it. So if you take it 4 as an LCM, so it will going to be 2r to the power 4 minus r to the power 4, r to the power 4. So 2 over 3 over 2 r cube times r to the power 4 over 4. So now 3, this is r cube r, so 3r over 8. That's the final answer. Yes, that's the final answer. Okay, so it's a method, just a method, remember the method. Okay, so B part of question number 5, they have given this diagram, a uniform solid hemisphere of radius r. So the radius of this hemisphere is r, is joined to a uniform solid rigid circular cone made of the same material, means same density, to form a toy. The cone has base radius r, so the cone base radius r, and height kr, so height is kr. The center of the base of the cone is O. The plane face of the cone coincides with the plane face of the hemisphere as shown in figure. The toy can rest in equilibrium on a horizontal surface with any point of the curved surface of the hemisphere in contact. So that means if you keep it on a horizontal floor, something like this, it's not toppling to any side. That means the normal reaction comes from the contact point, because it's in contact here. The normal reaction given from the ground should pass through the center of mass, because the total mass of this toy should pass through, the total mass of this toy and the normal reaction should meet at one point. So the weight of the toy, the total weight, if it is this way, the total weight this way, the normal reaction from the contact point also should pass. That means the center of mass should be on this line of action. If you keep it like this, center of mass should be in this line of action. So if you take we can use simply the principle of moments. That means for the hemisphere, the mass of it, so the center of mass will be at a distance of 3r/8. We already proved it. So the weight or the mass of the hemisphere will act here, m1g. The mass of the solid cone will be at a distance of, from the base, it will be at a distance of center of mass given in the data sheet, 1/4 of the height. So 1/4 of the height somewhere here, 1/4 of the height. So there its weight acts, weight of the solid cone acts m2g. So if you take moment about it, m2g into this distance must be equal to m1g into this distance. That's all. So we need to find the mass for m2g and m1g. So mass of solid cone equal. So the volume of the solid cone is given by 1/3 pi r squared h, 1/3 pi r squared. R is the radius of the circular base, pi r squared. H is kr. Here the height is kr. So the into the density rho. So they are saying same material means same density rho. Mass of the hemisphere (4/3 pi r cube divided by 2 means 2/3 pi r cube rho. Okay, center of mass of the hemisphere we already found it, 3/8 of the radius. This is 1/4 of the height. 1/4 of the height, that's given in the data sheet. So the moment about the contact point, clockwise moment equal anti-clockwise. So we can take like that. All the ratios should be the same. This ratio should be equal to ratio of the weights. Anyway, either way you can do it. So that means m2g, mass of the hemisphere, that is 2/3 pi r cube rho into 3/8 r. This one must be equal to, for the solid cone, 1/3 pi r squared into kr rho times the distance, 1/4 of kr. 1/4 of kr. Okay, so solve it. You will get pi r to the power 4 over 4 equal pi k squared r to the power 4 over 12. Check it. 12 pi r to the power 4 k, yes, to the power 4. Okay, rho will get cancelled both sides. Right, so from this pi get cancelled, 4 here 3, k squared. So k will be equal to square root of 3. That's the answer. Because it's in this position means the moment of the hemisphere and the solid cone on either side should balance. That's the idea. Okay, so question number 6. This diagram is given there. A particle P of mass m is attached to one end of a light inextensible string of length a. The other end is attached to a string. The center is O. The particle is thrown. By keeping the string horizontal, the particle is thrown down at a speed square root of 9 ag over 5. When the string makes an angle theta with vertical, downward vertical through O, and string is still taut, the tension in the string is S. So at this position, the tension is taken S. Show that S equal 3/5 mg within bracket 5 cos theta plus 3. Okay, so you know that first you must identify the center. We know this is the center. When it is at P, you should be able to identify the centripetal force. First you should identify the actual forces acting on P at this position. So if I draw the particle P, actual force acting on it are the weight mg and the tension towards the center. that makes an angle theta with vertical. So this string makes an angle theta with vertical, means alternative angle, this also theta. Okay, so the resultant force towards the center of the circular path is called centripetal force. So the tension is denoted by S here, not Ts, right? So I need to get an expression for T, the tension S. We know that resultant force equal mv squared over, so there V also comes. So I should find the speed at this position. Let the speed at this point, let it be V. Okay, so I can use the energy equation for the motion from A to B. We'll call this point B, particle P. Right, so we'll consider the motion from A to B. Loss in GPE, loss in gravitational potential energy equal gain in kinetic energy. By using that, we can find the speed at point B. Loss in GPE. Initially it was here, finally here. So the height through which it has fallen is this much. That is, in this right angle triangle, if you consider in this right angle, this length is A, the length of the string is A. So this height is this height, that is A cos theta. So loss in GPE, mgh, vertical height, it has fallen. That is h, this is the vertical height h. H is equal to A cos theta is equal to half m v squared minus half m u squared. U squared is this much, square root of 9 ag over 5 all in squared. Okay, so from this we can make the v subject or v squared subject. So here m will get cancelled. So Ga cos theta is equal to half v squared minus half half into 9 ag over 5. Oh, now how to solve, multiply the whole equation by 2 and make v squared subject. You will get v squared is equal to 2ag cos theta minus 9ag by plus 9ag by 5. Okay, so substitute that later in the equation for the tension, what I am going to get. Okay, so we'll write the equation for the centripetal force. This is the actual forces acting on the particle at position B. So S minus mg cos theta, resultant force towards the center of the circular path. Center of the circular path is somewhere here. This is the O. So resultant force towards the center, S minus mg cos theta is equal to mv squared over r. R is A. So instead of v squared, substitute this one. You will get m over A into 2ag cos theta plus 9ag over 5. Okay, solve it and make the S subject. You will get S is equal to 3mg cos theta plus 9mg by 5. That is S. Okay, so they asked to show that. We'll try to take it in that format. So that is, take 3 by 5 mg out of the bracket, 3 5 by mg. If I take it within bracket, it will become 5 cos theta plus 3. So they have to show this, right? Nothing from here. Take 3 mg out because that's the way the question says. So we have to take 3 mg out of the bracket. Okay, so what we did is A part. Now B part. At the instant when the string becomes slack, the speed of P is V. Show that V equals square root of 3ag over 5. Okay, so for that, we'll do like this. When the string slacks means S equals 0. S equals 0. We can use this as a common general equation in terms of theta. So S becomes 0. We have to show what could be the speed. So we already got the expressions for both S and V square. S and V square. S is the tension and V square in general format in terms of theta. So nothing. We'll find what could be the value of theta when S equals 0. Is it? That is the when the string slacks means the tension S becomes 0. We'll find the value of cos theta. Substitute that here. You will get the answer for that speed V. Okay, that's all. Okay, so we got the equation for S equal B part S equal 3 mg over 5 5 cos theta plus 3. So when the string slacks, S equal 0. So when the string slacks S equal 0 means substitute 0 equal 3 mg over 5 cos theta plus 3 equals 0, right? So this you can multiply or divide the 0. So finally you will get 5 cos theta equal minus 3 cos theta equal minus 3 by 5. What does it mean? Minus sign. Okay, we are measuring the angle from here with the vertical line. So the particle is moving this direction. Cos theta equal minus 3 by 5 means by using calculator find the theta, it will be 126 degree. So 126 means with this line it will be somewhere here. This is 90 degree. I draw the horizontal line, it's going to be 90 degree. So at this point the string won't slack, exactly the same speed according to the law of conservation of energy. The particle was thrown from here at 9 ag by 5 along the same horizontal line. The string won't slack because at this position started to move circular motion means here also it will move in circular motion, and the speed at this position will be square root of 9 ag of 5 because according to the law of conservation of energy, is it? So so the particle will be 126. If you find the theta, you will get 126.87 degree. We don't need it, but I'm just telling it. So 126.87 means this is 90 plus 36.87. So the particle will be somewhere here. When the particle is here, the string slacks. So the particle somewhere here. So at this angle, this whole angle from here to here, from this angle is 126. This angle is 126.87 degree. Anyway, we don't need it, but we need to find the speed. So at that moment, when the string slacks, there is a part, the speed becomes V. That is V. So just it's going to string slacks means it's just now only it's going to lose the circular motion. So what will happen when it loses circular motion? Actually it has passed the horizontal level, so it's going to follow a projectile motion. That's the next part they are asking, find the maximum height. So at this moment the tension becomes 0, means it's until that point it followed a circular path. Now tension becomes 0, so no further centrifugal effect. No further centrifugal effect means it's not following circular path at this point. So when the angle becomes this much, it's losing the circular path. So it's going to follow a projectile motion because it has speed. Speed is not equal to 0. So we need to find the V at this position. Right, okay, so it's not an issue. So already we got an expression for V, general equation, V squared equal, we already derive it in the A part, V squared equal 2Ag cos theta plus 9Ag over 5. So cos theta, substitute minus 3 by 5, so 2Ag into minus 3 by 5 plus 9Ag over 5. Substitute. Okay, and solve it. You'll get the answer. So this is going to be minus 6 Ag over 5 plus 3 Ag over 5. So 3 Ag over 5 is V square. So V is going to be square root of 3 Ag over 5. That's the answer. So at that point, it's losing the, it's going to lose the circular path. Then it's going to follow a projectile motion. So that's the next part. So beyond it, it will not follow a circular path. It's going to be a projectile motion, maybe something like this. It might follow a circular path. So the third part, find the maximum height above the horizontal level of force. So about this one, how much is this height? So maximum height, we don't know where is the maximum height. So it has a speed at that moment along the tangent. Then it will go a circle, maybe something like that. Projectile, maybe this height they are asking. So they are asking to find this height. Maximum height they are asking to find. So at the I drew the diagram again for part C. So this angle is theta minus 90 because we found that theta in B part is an obtuse angle 126 degree. So this is 90. So this is going to be, this is 126 theta. So this is going to be theta minus 90 when the string start to slack or just slacks. Beyond it, the particle will follow a projectile motion because when the string slacks, that means the particle has no centrifugal effect. That means the particle is not try to move away from the center. In the previous papers also I told when a particle moves on a circular path, it has the intention of moving away from the center called centrifugal effect. Due to centrifugal effect only there will be tension because the particle try to move away, so it stretches the string. But when the particle stops following circular path, it won't have any intention of moving away from the center, no centrifugal effect, no tension, so the string slacks. But when the string slacks at this position, the speed is not equal to 0. We found the speed in the second part. We showed that speed is square root of 3ag over 5. So at that point, when the string just slacks, at that point the speed is along the tangent, but beyond it, it won't follow circular path. So what will happen? It will follow a projectile motion. It's going to follow a projectile motion. So that's the question they asked, maximum height above the horizontal line. So it's going to follow a projectile motion. So from its position where at that time the string slacks, from that point it goes vertically upwards to the maximum height where speed equals 0. You know, projectile motion, the highest point, the vertical component of the speed equal to 0. So the vertical component of the speed. So the vertical force becomes, vertical component of the velocity becomes equal to 0 at the highest point. I took that height h2 from the point where it starts to lose the tension of the string. So from the horizontal line that passes through the center of the circular path, I took it as h1. So if I find this height, now it's completely not a circular motion. We can use projectile motion for the motion from this point to this point. Okay, so we can use vertically upwards, v squared equal u squared plus 2as. Don't get confused with s, they are using s for tension, so I'll put 2ah, I'll put h. Okay, so at the highest point the vertical component becomes 0, the speed. The initial vertical component at the point where it starts the projectile motion, where the tension becomes 0, is, we already showed it, that is square root of 3ag over 5. So this v is 3ag over 5 sine alpha, is it? So square root of 3ag over 5 sine alpha all being squared plus 2gh. Okay, so what sine alpha? Now this is theta minus 90. If this is theta minus 90, this is also theta minus 90 because alternative angle. Am I right? So that also theta minus 90. So what will be the alpha? We need the alpha for the projectile motion. So this is at the moment the string slacks, the speed velocities along the tangent. So this is 90 degree. This is 90, the velocity with this line 90 degrees. So alpha is equal to 90 minus 90. Alpha is equal to 90 minus This is alternative angle. This is alternative angle. 90 minus theta minus 90. So that's going to be 180 minus theta. So sine alpha is equal to sine of 180 minus theta. So we'll solve further. 0 equal to square it 3ag over 5. 3ag over 5. Sine squared instead of alpha 180 minus theta plus 2gh. So upward, so it's going to g is anyway negative because gravitation is downward, so minus. So here we should minus 2gh because I'm taking upward direction. Okay, so we know that sine 180 minus theta is sine theta. Sine 180 minus theta equals sine theta. In the first part we got cos theta equal 3 by 5. We got it in the A part. Cos theta equal minus 3 by 5. So minus 3 by 5, that means 3 by 5 we can take it. Cos theta equal minus 3 by 5. So how much will be sine theta if we want to find here sine 180 minus theta equals sine theta. How to find the sine theta? If you want, you can find the value of theta by using calculator. You will get 126 odd. Then find the sine value, you will get 4 by 5. Or you can use this value, this sine square theta plus cos square theta equal 1. So when you square it, it will become positive. So sine squared theta plus minus 3 by 5 all things squared equal 1. So from that find the sine theta, you will get 4 by 5. Anyway, you can find sine theta equal 4 by 5. Either you can find the theta value and take the sine of it, you will get 4 by 5, or just think this way also. You can get sine square theta plus cos theta equal 1. So cos square theta minus 3 by 5 all things squared, sine square theta, solve it, you will get sine theta 4 by 5. So it's not an issue. So we'll substitute here. 0 is equal to 3, g will get cancelled here. So that is 3a over 5 sine squared theta. So that is sine squared theta. Sine squared theta means 4 by 5 all things squared. Sine squared 180 minus theta equals sine squared theta. Sine squared theta 4 by 5 minus 2h1. Sorry, 2h2. h2 I am using. Sorry, 2h2. Right, so from this, find the H2. How much will be the H2? Solve it and get it. So H2 will be 0 equal 3a over 5 into 16 over 25 minus 2H2. So solve it, you will get H2 is equal to 24a over 125. Yeah, 62 divided by 8, 8 into 3, 24. Yeah, this A. So you'll get 24a over 125 is the H2. But how much is H1? We need to find the H1 also. H1 is going to be A sine theta minus 90. H1 is equal to A sine theta minus 90. So that will be minus A cos theta. Is it? H1 is equal to minus A cos theta. But cos theta equal minus 3 by 5. So from this I can continue. H1 is equal to, so H1 is equal to minus A cos theta minus 3 by 5. So that will be 3a over 5. Right, the question is find the maximum height, this one, h1 plus h2. So h max, h1 plus h2, h1 3a over 5 plus h2 24a over 125. Solve it. You will get 99a over 125. That's the answer. Maximum height reached by the particle. Okay, so question number 7, the last question based on simple harmonic motion. This diagram is given, but I added other data also what's given in the sentence also. So they are saying AB, the particle is oscillating between A and B are the 2 points, and the particle when it is at this position, it's at rest. And they are giving AO 3 meters, OB 2 meters, because the total length 5 means 5 minus 3, this is 2 meters. And the natural length of the string AO, the natural length of the string AO is 2 meters, and the natural length of the elastic string BO is 1.2 meters. So it's, we know that extension of the string AO is 3 minus 2, 1 meter. Extension of this string is 2 minus 1.2, that is 0.8 meters. And also it's given that modulus of elasticity of this one is given 20 Newton, but this is a question, lambda, we need to find it. Okay, and they are saying the particle is at rest at O. So if the particle is at rest at O, the resultant force acting on the particle must be equal to 0. So the A part show that lambda equal 15. Lambda equal 15 means the modulus of elasticity of the second string OB, we have to show it's 15. Okay, so we can answer like this. A part. The extension of the string AO is, we can say x1, that is equal to 3 minus 2, that is 1 meter. Extension of the second string x2 equal to minus 1.2, 2 minus 1.2, that is equal to 0.8 meter. Okay, we know that both extensions. So it's at rest. So if I draw the forces acting on the particle, there are only 2 forces acting on it. The vertical normal reaction and the weight balance each other, that won't involve in the oscillation. So this side there's a tension T2 and there's tension T1. Okay, we know that since it's at rest, T1 must be equal to T2. There's no resultant force because it's at rest. T1 must be equal to T2. T lambda x over L, or lambda over L into x. So this is lambda 1 over L1 into x1 equal lambda 2 over L2 x2. Lambda 1 we know that, that is 20. L1 we know that 2. X1 we know that 1. Lambda 2 is the question which is denoted as lambda. L2 we know 1.2 and x2 that is 0.8. Okay, from this solve it, you will get the lambda. So lambda is equal to 15 Newton. That is the modulus of elasticity of the second string OB. Okay, so B part, they are saying the particle is now projected along the floor towards B. So it's projected towards B. At time t seconds, P is a displacement x meters from O in the direction of OB. So it has displaced, it has a displacement of x meters. So the particle has come to a new position somewhere here. This displacement is x. They are saying it. This displacement is x. They are saying it. So if that displacement is x means, now we take x is less than 1.8. We'll take it like we'll take it as it's smaller than the extension 0.8 of the second string. Okay, if it is x, we arbitrarily take x. Then the extension of the second string will decrease by x, because earlier the extension of OB is 0.8. Now it's shifted to the right through x means the extension of the second string will become 0.8 minus x. But the extension of the first elastic string AO will increase by x. It will become, already it has extension 1 meter. Now it will become 1 plus x. Now what are the forces acting on the particle? So B part, if I consider the particle, still I'll use the same notations, T2 and T1. Now T2 and T1 are not same, because when it was at the equilibrium position, they were same, they have the same numerical value, magnitude, same. But now it has extended to the right, means T2 will become smaller and T1 become larger. T1 is going to increase because its extension is increasing. It was, both tensions were balanced at this point. But anyway, when they are balanced, they have the same tension, but when you increase the extension of this one, then tension also will increase for the first string. So T1 will become greater than T2. And I'm going to write the Newton's second law, F equal ma or F equal mx double dot. Along the direction of displacement, we take it positive, keep it in mind, then you will get the proper pattern to show that it is performing single harmonic motion. X double dot equal minus omega squared x. That format, if you want to take along the direction of displacement positive. Here they are saying it's thrown to the right, so we'll take it towards right is positive. Anyway, before that I'll write T1. Now it's going to be, lambda over L into x. So lambda 1 over L1 into extension 1 plus x. It was earlier 1, now 1 plus x. T2 is equal to lambda 2 over, we found the lambda 2, we'll substitute later, lambda 2 over L2 into, it was earlier 0.8, now decreased by x, 0.8 minus x, right. So we'll take the second law in this direction, F equal mx double dot. Along the direction of displacement, we take it positive. So any quantity along the direction of displacement will be taken positive. So T2 is along this direction. So T2 minus T1 equal mx double dot. M is given anyway, we'll substitute 1.25, I think, yeah, 1.25. Okay, T2, that is lambda 2 over L2. Lambda 2, we know that, so that is lambda 2 is the lambda. Is it lambda 2 means that is lambda. Lambda 2 is the lambda, that is 15 over L2. L2 is 2, the natural, L2, the natural length was 1.2 into extension, that is 0.8 minus x minus T1, lambda 1 over L1. Lambda 1, we know that 20 over 2 into 1 plus x equal, mass is given 1.25 x double dot. Okay, solve this equation. Okay, you will end up with the equation that they asked to show. You can use the calculator or anything. You solve it normally. You'll end up with x double dot equal minus 18x. So now we can show that this is a constant. 18 is a constant. Therefore, omega squared equal 18 and x double dot proportional to minus x. So it performs simple harmonic motion. Okay, so part C, the initial speed of P is 10 meter per second. Sometimes they give what is the impulse given. From that also we can find at what speed it was thrown from the equilibrium position. Here they are giving the speed directly, but in case if it is not given, they will give it impulse. We can find that also by using I equal mv minus mu. But here the speed is given 10 meter per second. So initial speed is given 10 meter per second at the equilibrium position. So that is the maximum speed. You know the equation, v squared equal omega squared into a squared minus x squared. According to that, at the equilibrium position, x equals 0. You know in this equation, x is the displacement that is always measured from the equilibrium position. So when x becomes 0, we will have the maximum. You know algebra, we are subtracting a value because x becomes 0, then v will be the maximum. So the maximum speed occurs at the equilibrium position, which is square root if you take v square equal omega square a square when x equals 0. So v maximum equal a omega, which is given as 10 meter per second. So from that we can find the amplitude of the oscillation. So this is C part. So v max given, v max equal omega a when x equals 0, is it? At the equilibrium position, that happens. Okay, so V max is given, that is 10 meter per second. So 10 equal, omega we found it, omega squared we found it, that is 18. So omega is going to be square root of yeah, we can put like a 3 root 2 or whatever it is. We can find it in numbers also if we want the value. That is anyway, omega is going to be square root of 18 times A. Okay, so we can find the amplitude of oscillation. So this is square root of 18 could be written as 9 into 2. So 3 root 2 we can write it, no problem. 3 root 2 into A. So amplitude A is going to be 10 over 3 root 2. If you want, you can find it is in decimal point. Okay, I found the amplitude now. Now the question is find the speed P at the instant when the string PB becomes slack. When the string PB becomes slack, now this is the particle P, PB becomes slack means the particle should move towards right such that the string, this one PB or OB, whatever it is, slacks. We know that its extension is 0.8 meters. So if the string PB or OB wants to slack, that means the displacement of the particle must be towards right 0.8. Is it? Already when it was at the equilibrium position, the extension is 0.8 meters. If it wants to slack, it should go to the move towards right through a displacement of 0.8. So the string OB will reach its natural length and won't have any extension. So they're asking to find the speed when the string OB or PB slack. Okay, so that's not an issue. So we can use the same equation again. We found the amplitude. So we'll use towards right E squared equal omega squared A squared minus x squared. Okay, so that means the displacement should be 0.8 meters when it moved to the right. So omega squared anyway 18, is it? I found it earlier, omega squared 18 into A squared. So that is going to be 100 over 18 minus x squared. The displacement towards right should be equal to extension of the string PB. Then only the string PB will slack. So that is 0.8 squared. Okay, so solve it. You will get the V. So V will be equal to 9.41 meter per second. Okay, so next question, little bit carefully we have to answer. It's a 6-mark question. That's the highest mark in this question number 7. So both strings are taut, means under tension, for time t seconds during the one complete oscillation. Find the value of t. Okay, so careful there. Now we know that this is the points A and B. This is A, this is B, O was here, right. So when the particle was at O, we know the extension of the left string that was 1 meter and the extension of the second string which is 0.8 meters. And it was projected from the equilibrium position at a speed of 10 meter per second. That is the maximum speed. And we got an equation for the simple harmonic motion, that is x double dot equal minus 18x. Okay, when we derived this equation, we took both strings are under tension. Careful. We took both strings are under tension. You can see the part B part there. I took both have extension, both are under tension, T2 minus T1. From that I solved and got this equation. But when it was projected at speed 10 meter per second, we don't know what is the maximum distance it moved to the right. We didn't calculate and we don't need to find it, but it could happen. What could happen? The particle could move to the right beyond the point where the string PB slacks. Means when it goes beyond that point, what happens? The string PB might slack. Only this could be the tension acting on the particle, and the tension T2 might become 0. So when it comes to rest somewhere here, it could be the extreme position, but at that time the tension might be 0 and the distance it would have moved to the right maybe more than 0.8 meter. So if that happens, the equation x double dot equal minus 18x is invalid. The reason this is valid only when both are under tension. So this equation is valid when both strings are under tension, both strings are taut. That means when the particle is to the right, we'll name that point A, O, we'll name that point C, where this extension 0.8 meters, and on this side we'll name it D. Are there any D used? No. This is 1 meter. It might go beyond 0.8, it might go because of this speed, the particle might move beyond C, then the tension T2 will become 0. This equation cannot be applied during that time because we derive this equation by considering T2 minus T1, both are under tension. So during one full oscillation means maybe the particle would have come to this position where this is invalid, then it comes here. When it reaches C, yes, this equation is valid, and omega squared is 18. So from C to O it will move, then O to D it moves. In case if it moves beyond that, again this equation is invalid. It might come to rest somewhere here, then it moves. So the question is, during one full oscillation means we don't know whether it's reaching a point where this equation is invalid. We don't need to worry about it, but we need to consider that during one oscillation means maybe this point, if I say E, this point F, we don't know. If it moving from E to F, that means, or we'll start the motion from O, it takes time to move from O to C, then C to E we don't consider, then E to C we don't consider, C to O we will consider. Then O to D we consider, D to F we don't consider, F to D we don't consider, D to O we consider. So that means during one oscillations we need to consider that time taken to travel from O to C, then C to O, then O to D, then D to O. We don't consider the time beyond C to the right and beyond D to the left. We are not going to consider the time taken for that. So the question is clear. They are saying both strings are taut for T seconds during one complete oscillation. So it might slack, but we are not going to consider the time duration the string, one of the string gets slack. Okay. So anyway, also because that equation is, this equation is not valid when one of the string gets slack. Right. Okay. So we'll find the time to travel from O to C, then C to O. If it is moving beyond C, we will just ignore. It might go to E. We don't consider. E to C, we don't consider. Then when it comes from C to O, yes, we will consider that time. But you must know the time taken to travel from O to C and C to O are the same. I told that when I was explaining the first question or somewhere today. Yeah, first question I told that during simple harmonic motion, when the particle moves between 2 points, the time taken to travel from one point to the next point does not depend on the direction of motion. The time taken to travel from O to C same as C to O. Time taken to travel from O to D same as D to O. So we need to find the time taken for during one oscillation. So during one oscillation, that is given T such that that string is under tension. So T is equal to time travel from O to C plus time travel from C to O. Beyond the C we are not considering, plus time taken to travel from O to D plus time taken to travel from D to O. Beyond that we are not going to consider. This is the time we need to find it. But time taken to travel from O to C and C to O are the same. So 2 times OC plus 2 times OD. Right. If we find it, that's the end of the question. We'll get the answer. Careful, because bit tricky. You should think carefully and answer it. Okay, so I hope you understood what I'm going to do now. So I'm going to find the time taken for O to C and O to D. Right, so that's very simple. We know O to C, we'll take the particle is at O at the equilibrium position. How long will it take to travel C? So that is x equal A sine omega t. When t equals 0, x equals 0. So I need to use the equation x equal a sine omega t. Can't use cos omega t because we don't know how much it moved to the right or how much it moved to the left. There we can't use the simple harmonic motion equation because one of the strings getting slack. We can't use it, right? So x maximum it can move to the right such that both strings are under tension, means maximum maybe 0.8 meters we can take, that means 0.799999 0.8. Okay, in that case also we can take the both strings are under tension, so that is 0.8 equal amplitude amplitude we found it already, that is 10 over square root of 18 sine omega square root of 18 into TOC. So keep your calculator in radian mode and find TOC. So TOC you will get 0.082 seconds. Same way, find for the motion OD, again use the same equation, that is 1 equal 10 over square root of 18 sine square root of 18 into TOD. So find the TOD. So that is you will get 0.103. Okay, so we need to find the T. T is equal to 2 times TOC plus 2 times TOD. I already explained that. Time derivative from O to C same as C to O. Same way, time derivative from O to D same as D. So that is 2 into 0.08 082 plus 2 into 0.103. So that will be 0.370. That's the time T. Okay, so I hope you understood. We'll meet during another paper discussion.